This is for methods, year 11 methods. We're going to look at exercise 5C, question number 5. Okay, so we're looking at basic function notation and how functions work. So before we go through this example, just going through basics, if I define a function as a linear 2x plus 1, and I were to change the x here with another letter, so say a, then you replace all the x's in the equation with a. So you go 2a plus 1. So if I had f of a plus 1, then instead of replacing with x, I replace with a plus 1. So we'll go 2a plus 1, which equals 2a plus 2 plus 1, which equals 2a plus 3, etc. If I were to go f of 1 over a, then I replace the x with 1 over a plus 1. So something like this. Okay, and when you make it the same denominator, then it will be 2 plus a of a. Okay, so we're doing something similar here. We're replacing the x with another number. So what this is doing is we're subbing in x equals 1 in a sense. Okay, so if I want to find f of 1, I'm essentially finding x equals 1. So what does that thing equal to when x equals 1? So f of 1 basically equals to 1 minus 1 over 1, because instead of x we have 1 now, which equals 0. Okay, f of 1 plus a, so f of 1 plus a equals 1 minus 1 over 1 plus a. Now I suppose you'll get confused as to how the book answers this. It's simply, I can change the 1 as a fraction of 1 over a, 1 plus, as a fraction of 1 plus a, because 1 plus a on 1 plus a is the same as 1, isn't it? Or anything divided by anything is the same, is equal to 1. So 4 divided by 4 equals 1, 5 divided by 5 equals 1, a divided by a equals 1, etc., etc. 1 plus a divided by 1 plus a equals 1. Minus 1 on 1 plus a. So since the denominators are the same now, I can subtract the numerators. So 1 minus 1 is 0, and you got with a left over a, 1 plus a. Okay. Similarly, for 3, if I sub in 1 minus a for x, I do the same thing. I change the 1 into a 1 minus a, divided by 1 minus a, minus 1 on 1 minus a. Okay, so essentially I've got minus a on 1 minus a. Okay. I'm not sure if the book did something tricky like this. They could move the negative here downstairs. So technically you can move it like this, and you can just swap the signs to make it a minus 1. Okay, they're the same thing. I'm not sure if the textbook does that, but you're welcome to check. For part 4, instead of x we have 1 over a. So we've got 1 minus 1 over a. Oh, hang on, sorry, apologies. We have 1 minus 1, x happens to be 1 over a, so it's 1 on 1 over a. Okay. The trick is, when you're dividing a fraction with a fraction, you can multiply this with the top. Okay, so essentially what this becomes is 1 minus a. Okay. The reason that works is because we've got 1 divided by 1 over a, so in order to make that times, we need to flip the top, so it becomes 1 times a over 1, which equals a. Okay, does that make sense? So essentially that becomes 1 minus a. So that's why f is 1 minus a as the answer. So I know this this question sort of tests you on your fraction skills. You do need to get very comfortable with fractions. Okay, if you're not, just practice. There's no way around it. There's no magic pill to learn it. I mean, I can teach you tricks, but ultimately you need to understand it. So for question 9, it says consider the function f of x equals 2x minus 3, find f of 2 and f of negative 4. So we're subbing in x equals 2 and x equals negative 4. So f of 2 equals 2. 2 squared minus 3. 2 squared is 4. 4 times 2 is 8 minus 3. Okay, which is 5. Now, I do want to start students to start doing this in your head, okay? Because if you write too many lines, one, you can easily make mistakes the more lines you write, and secondly, you're saving time by doing this. Okay, so it's better. F of negative 4 equals 2 negative 4 squared. Remember, whenever you're squaring any number, it's always going to be positive, whether it's negative or not. Okay, so 4 squared, 16. 16 times 2 is 32. 32 minus 3. Oops, 32 minus 3 is 29. Okay. Find the range of f. What is this graph? Think about it. Okay, just because we have f of x notation doesn't change the fact that it's essentially like 2x squared, y equals 2x squared minus 3. And we know what that looks like. Just because I change the y to a f of x shouldn't change how we view it. So it's just an x squared graph, essentially, with dilation, it just looks thinner, and it's been moved down 3. So it looks something like this. So we're at negative 3 here. We don't need to find the x-intercepts because that doesn't affect our domain. So our domain, if we look at the graph, is reals, because it can go to infinity and beyond from here, and to infinity and beyond from here, or to negative infinity and beyond on both sides. So the domain's reals, and the range is from negative 3 to infinity. You're starting at negative 3 and goes to infinity. So range is including negative 3 to positive infinity, not including. Okay, does that make sense? So that's essentially what you're doing. The domain, if I want to visually represent it, the domain, it spans forever here and there, because the graph goes on forever that way, forever that. So that's what reals. And the range only starts at negative 3 to infinity. Okay, hopefully this helps.